in the last lecture, we stopped at this particular point. The There are different types of modalities. There are different types of brain signals which are used in brain-computer interface: EEG, MEG, functional MRI, functional near-infrared spectroscopy. And if you remember, yesterday I was telling you the most popular, most commonly used modality is EEG, that is electroencephalogram. Electroencephalogram is very popular because you can see the reason: it is non-invasive in nature. The spatial resolution is not very high, and but the temporal resolution is okay, and it is absolutely portable. You can carry easy device anywhere you want to capture, and it captures the electrical signal. But why it is popular? The reason is portability. Second is very economical. It is not expensive. You can even get a headband kind of EEG device, maybe of around 100 or 200 US dollar. That is also available in the market. Of course, that is not very powerful. You can just wear a hairband, I mean headband, and where it will have two electrodes or two sensors. So the signal acquired will not be very strong, but yeah, it's portable for studies. So how do we record the EEG signal? This is a pictorial representation. You can see here the person in a biomedical study or a brain computer interface. We call the person as a subject. So the subject wears a cap like structure, hat like structure, where all these nodes are electrodes, and all those electrodes are nothing but sensors. So you just wear, and what happens that those sensors, those electrodes capture the brain signal from different parts of the brain. And when you bring those brain signals through the channel, you get signals like these. So you can see that is small variation of electrical potentials coming from different parts of brain, that you can see. Yeah. So from different parts of the brain, different channels, these are, the sensors which capture the brain signal from different parts of brain. Non-invasive uses the surface electrodes. And why I was telling you EEG is very popular, because it is absolutely safe. It doesn't harm your brain, and painless. You do not need to insert the needles. You do not need to do any surgery. Human EEG can be measured using special electrodes with a typical diameter of, how much is the diameter of these electrodes? It starts from zero point 0.4 centimeter to 1 centimeter. That much is the diameter of the electrode. The electrodes are placed on where those electrodes are placed, those electrodes over the head, over the scalp with a paste. Those electrodes are generally placed either by using some weight or dry. There are two types of electrodes. One is dry electrode and second is wet electrode. So what is the meaning? So when you put wet electrode, it means you put some gel, some gel that provides conductivity between the sensor and the scalp. So we put a gel that provides better conductivity. So in that case we call it as a wet electrode, otherwise dry electrode. So dry electrodes are also powerful electrodes that capture the brain signal. So this is how recording is done. There are different standards of recording: 1020 system, 1010 system. We will discuss later on, but this is how typically brain signal is recorded. All right. And then when you record brain signal, you need some computing. So nowadays, as I mentioned, that smaller version of EEG devices are coming, called as mini EEG devices. We will discuss later. But what is the use of computing? See, When you capture the EEG signal, you need to acquire the signal, you need to pre-process the signal, you need to translate that signal into command. So for that, for every operation over the signal, you need some signal processing, you need some computation, you need some mathematical modeling. And then further, you need some ML models, you need some optimization techniques, hardware design, IoTs, and protocols. These things I will explain little later. I will try to explain you that what is optimization technique. Why is an optimization technique used? Optimization technique is used, if you remember, I was telling you that see, there are many electrodes, and if you can also recall, in our previous lecture we have discussed that there are different parts of brain: temporal area, parietal area, and there are different areas. So from a particular area, if you capture the brain signal, so the particular area is covered by many electrodes. So are all electrodes bringing the meaningful information? That might not be true. So what is important is which channel is more appropriate, which channel from which particular part is bringing more important information. So channel level optimization, and then from each channel you bring a lot of data, and then you extract huge amount of features. So which features are more important? So channel level optimization, feature level optimization, these are the optimization techniques used in brain computer interface. Because what happens when you cover the information from all the channels, when you include all the features extracted from all the channels, the dimensionality increases, and therefore optimization techniques are used. What are the basic challenges? What are the fundamental challenges in brain computer interface? The biggest problem is poor signal to noise ratio. Hope you understand this terminology. Signal to noise ratio, it is always desirable, to be higher value. So if signal to noise ratio is poor, what is the reason? The reason for poor signal to noise ratio is, some introduction of noise in the original signal or artifact. I hope I have explained about the artifact in my previous lecture. I have already explained. Artifact is some unwanted effect that may be due to some technology, due to maybe some psychological effect. You are blinking your eyes, you are moving your hand, you are moving your motory organs while EEG is being recorded. Generally, when EEG is captured in BCI application, the person is suggested that be calm, do not move your hands, do not blink your eyes. So these are the protocols. But when you do not follow, some technical artifact, some movement related artifact would be introduced in the original signal that degrades the signal quality, and therefore poor to signal to noise ratio is a problem. Implantation of electrodes, where exactly electrode have to be implanted, where electrodes are to be placed appropriately, that is always a challenge. High dimensionality of data, I have explained about high dimensionality of data, large number of features, information transfer rate and selection of channels. I have also explained you about the selection of channels, which channel is more important. That plays very important role. Variation between different individual, and the biggest problem I can tell you is difficulty in obtaining precise and accurate results, because brain is very sensitive, brain is very complex organ. So obtaining the precise and accurate result from human brain, and that too, if you remember, I was telling yesterday, the study is purely subjective. If you study a brain of an individual in a particular area of brain, you go to another person, there might be variation, there might be change. If you are asking two persons, watch this movie, watch this picture, and that stimuli, how does stimuli react, how is stimuli reacted or responded by two individuals, might have difference, might have variation. So it's purely subjective, and therefore it's not that much easy. But when you include more number of people, more number of subjects, and when you capture more amount of data, you still get the clarity, and you still get what I can say conclusion that what is the importance of which part of the brain. So then comes cognitive engineering. It is nothing but application of cognitive science theory to human related factors, human related problems. The main aim of research in the area of cognitive science and engineering is to develop the tools so that the tools can be used with less cognitive training to solve the applied problems. We will discuss about this little more. About robotics. Robotics is another interesting area where cognitive science is of immense importance, because robots have ability to perceive, have abilities to move, have abilities to walk. So how does it take decision? The decision making of robot, sensing of robot, perception ability of robot, movement of robot, it is all governed by, controlled by your brain. I mean, is it possible? The answer is yes. And therefore, the cognitive science concept, rather brain computer interface, plays most important role in the area of robotics. If you do not apply, if you do not want to apply cognitive science in robotics, it's okay. You can develop a microcontroller based robots just to operate in certain direction, just to do some intended tasks. But if you want, you know to control the robot for an application that is controllable by your brain, it is absolutely possible. So in that case, what is important? You have to have an architecture, you have to have human cognition, you will get the data from human brain that will be interpreted. Lot of data needs to be trained. Remember, how does a robot get understanding? How does a robot get abilities? Please try to understand. Huge amount of data from large number of people, from large number of brains, that is trained, and then only it develops the knowledge base, it develops the understanding, and then it is used in the robotics. So engineering robots whose actions are functions of knowledge, preferences and plans, and whatever is the act on the basis of human like actions that is performed by the robots. So when you talk about cognitive modeling, in the center of cognitive modeling, there will be human brain, and the terminologies which are used in the cognitive modeling are artificial intelligence, machine learning, ML, data mining, and cognitive modeling. So cognitive modeling depends on all these three, and all these three depend on human brain ability and the brain signals. And we know that the cognitive system is very complex, and therefore we need different models, and those models can understand the cognitive ability, cognitive understanding. Cognitive understanding means what? Understanding by using the human brain, understanding by using the brain signal. And for that, you need some model, so that understanding how integrated cognitive system affect and are affected by the environment. Here, environment is nothing but stimuli. Stimuli, whenever you say stimuli, stimuli is a plural number, plural, word. Singular is stimulus. Stimulus means you're watching a movie. So picture intensity is stimulus. You are hearing something, so audio is a stimulus. So whatever, your sensory organs are tongue, ears, nose, eyes. So whatever you perceive, whatever you detect, whatever you sense with the help of your sensory organs are stimuli. So how does human brain respond to stimuli? And that's very important. And for that, what do you need? You need to understand the brain signal. You need to interpret the brain signal. So the basis of brain computer interface is, it begins with interpreting the brain signal. The first stage is to understand the brain signal. Then you will go to translating the brain signal into suitable commands. So computational linguistics will be there. a language that involves understanding of semantics and syntax. It may involve signal processing. When you talk about computational linguistics, it includes many, many things: psychology, AI, computer science, language engineering, human computer interface, philosophy, logic, mathematics, statistics, signal processing, and so on. I mean, there is a very interesting term called as HCI. HCI stands for human computer interface. I mean, is there any difference between human computer interface and brain computer interface? Does anyone want to respond to this question? How HCI is different from BCI? How human computer interface is different from brain computer interface? I'll be glad if someone can answer to this question. Anybody wants to participate? How different? Yes, please go ahead.
There is a different method of interaction between the interfaces. Is kind of on different channels.
Okay, kind of different channels you will be using. Okay, anything else? Can you explain a little more what you are saying, that you will use different channels, then it becomes, can you further explain little more about the difference between HCI and BCI?
Yes, in human computer interface, we use methods of inputs that are touch screens, mouse, keyboard,
Okay.
while in brain computer interface, as far as I understood it, we use brain waves as an input for the system.
Very good, very good. Yes, absolutely. So, human computer interface, I mean, you are interfacing computer with human. So, there may be hundreds of applications. For example, suppose human being, a person using technology. You go to rural area, you go to a place where you ask so many people, when you're using technology, what is your feedback about the technology? How do you feel when you are using some touch screen technology? What is your experience? So you get different inputs from human being, you get different feedbacks from human being, you collect different responses from human being on different things, maybe related to technology, maybe related to development. You ask a number of queries, you ask a number of questions to human being. You can do a survey also. You just perform a survey, that survey about anything, survey about a product. Suppose you want to generate a model, you want to develop a model that can predict the rating of a product, how how good is the product. So what you can do, or you want to do the sentiment analysis. Hope you understand the term sentiment analysis. Suppose uh, you know many people are posting some comments on X. Earlier the name of X was Twitter. So if somebody is posting some comment on Twitter, on the basis of those comments, can you understand the sentiment? Or a particular technology or a product is used by so many people, you ask so many people so many questions, so you are getting inputs from human being, and those inputs are brought inside the computer. You do some modeling and conclude something, and your conclusion, may be the rating of a product, maybe developing some inference system. So this is the example of human computer interface, where there is no role of brain. Of course, psychology can impact. You are asking many questions to many people, so it depends on psychology of a person, how a person responds. Please believe me that if you're asking a person how good a product is, the person who is responding might not be always correct. The person might say that the product is very good, the product is good, even though it is not good. The product is excellent, even though it is not excellent. So it depends on psychology. Hope you understand the meaning of psychology. Psychology means, I will give one more example. Suppose somebody is doing some mindfulness practice. Hope you all have heard about some meditation. So if somebody is doing meditation, meditation is being practiced all across the world now. All across the world, you go to Instagram or other social media, you will find so many people doing meditation, and they will say that meditation is helping them to reduce their stress, to reduce anxiety, to improve the quality of life, to improve the sleep. So when you ask somebody, when you do the meditation, how does it impact? The person can say that, oh, it's doing great. It's improving my sleep quality. How much sleep quality is improved? Person might not be able to exactly tell you the quantity. So this is completely psychological. Someone can say that it's very high, somebody else can say that not very high. So it's completely psychology. So what I'm trying to say that psychology is something that is very common in human computer interface as well as your brain computer interface. Let's not spend time, but I think this is also very important to spend time here, because cognitive science is something that includes psychology, philosophy. We'll discuss more about philosophy little later, and of course, logic building, language, and everything. Because when you want to represent your knowledge, let's understand data, information, and knowledge. Whenever there is a data, what do you do with the data? The data may be brain signal, the data may be sensory input, the data may be image, the data may be speech. What do? You capture the raw data, bring into the computer, you extract the features, those features become information. Why do you extract so much information? So that you can classify and you can convert into knowledge. So please try to understand. You start with data, you convert into information, and finally you develop the knowledge. And whenever you acquire the knowledge or develop the knowledge development is not possible without logic, that is logic building. It requires syntax, it requires semantics, it requires language, it requires linguistics. And of course, when you are converting data into information, when you are converting information into knowledge, mathematical models are needed, mathematical equations are needed, mathematical concepts are needed, statistical parameters are needed, statistical modeling is needed, and therefore, mathematics and statistics. So whatever has been included in this picture is it plays a pertinent role as far as the cognitive science application in BCI is concerned. And this particular picture is talking about perception, and then when we perceive something, how do we act? So what happens that there are a lot of data, and you just receive the data. The data may be related to and see, please try to understand, whenever you whenever you perform certain study on brain computer interface, when you want to study about the brain, you you cannot conclude with the help of three persons, you cannot conclude with the help of only one gender. So in order to generalize your finding, you need to include gender, you need to include age, you need to include different age groups, you need to include different genders, you need to include different habits, you need to include different state of mind, you need to include different timing. If you are covering, if you are including only, say, you are recording EEG for a particular time, it may not be very appropriate. Let me give you one example. Let me just give you an example. When you want to study about, suppose you are doing some mathematical task, you are solving some complex problems, and we want to understand how do you develop, how is your learning ability improved. I have already explained you there is some area in the brain that can help you to understand how much learning is improving, how much is the learning impacted with the help of brain signal. So you can say that, yeah, 1 hour or 2 hours of study, 2 hours of complex problem solving is improving my learning ability. So what do? Before you solve the complex problem, record the EEG. Once you solve the complex problem, again record the EEG and compare the EEG signal, compare the brain signal. You will say that, oh, the gamma energy is increasing. If you remember yesterday, I have already briefly explained about the gamma energy. So you will say that gamma energy is increasing. It might indicate that the learning has improved. But remember what I'm trying to say, that why timing is very important. You cannot simply say you have to do 100 times. You have to do with 100 different persons. You have to do with males and females, girls and boys. of different age group, then you can, bring some general purpose conclusion that yes, this is working. So the perception is very important. How do you do perception? With the help of your sensory organs, your motory organs, and integration of these motory organs and sensory organs will help you the cognitive ability. Computational neuroscience, I hope computational neuroscience is very clear from this picture. Look at the picture here. EEG signal is there. EEG signal may be from a particular area like temporal area or a parietal area or a frontal area. So what do? You capture the EEG signal, and then you can understand whether the person is active, whether the person is passive, whether the person is aggressive, whether the person is assertive, whether the person is happy, whether the person is not happy. I mean, believe me, you can understand about the mood. You can study about the mood. You can study about the happiness. You can study about the stress. I mean, the level of stress is very difficult, but you can detect the impact of something that is causing the stress in human brain. That study is very well possible. So there are a number of mathematical tools, computational modeling, computational tools which are used to develop theoretical models, which are used to understand behavior and different abilities, different modes of human brain, not just to create intelligence, but to eliminate the processes related to sensation, perception, control of action, learning and memory, language, and other cognitive process. So remember, each neuron matters because brain consists of more than 84 billions of neurons, and all those groups of neurons respond to whatever you do. They respond to every stimuli, and stimuli may be because of, stimuli might be from negative activity, positive activity, or any other activity that will cause different kind of brain signals to be generated. There has been a lot of advances, like you see here. EEG is recorded, and then if you can remember, I was explaining you yesterday that even if in the brain computer interface, it is possible to generate some feedback signal, and the feedback signal can be given by either robot or can be given by the computer, and then the person can correct the behavior, or the action. The technological advancement, especially in the healthcare, is discovering the mysteries towards solving several underlying challenges. And you can also control the machines with the help of brain computer interface. P300 BCI, I was trying to give you an example yesterday. P300 BCI is very popular. I will explain about P300 BCI in detail, in coming lectures. So you see here, this picture is repeating again. But what is interesting here, I hope you can see here, there is some monitor, display kind of thing is there in front of this particular person. Say this person is affected with certain disability. How does brain computer interface work? Suppose this person wants to control the switches, control the light, control the refrigerator, control the television at his or her home. How can the person control? So what is there? These are the visual stimuli, and then the person can be trained. The person can be asked to watch this particular dot for 1 minute, can be asked to watch this dot for maybe 30 seconds. You ask the person that watch this dot for 30 seconds, and that particular thing can be connected with switching on the light or switching off the light. You can say that watch this particular dot for 20 seconds. That could be connected with either switching on the television, switching off the television. So this is how brain can control the different switches. So you just ask the person that you're just watching this. So when you say this person, whenever you want to switch on the TV, whenever you want to switch on the TV, you'll ask the person watch this particular dot for 20 seconds. So next time, whenever he is interested to switch on the TV, he will watch this particular dot for 20 seconds. Because what you have done, you have already trained his data. He was watching the that particular dot for 20 seconds, and that time you have decoded his brain signal. So that equivalent brain signal is controlling the relay, and the relay can control, it may be a wireless module that can control the navigation control, either maybe relay or some switches that can operate the robotic vehicle, or that can operate the home appliances, that can operate different number of switches. So interesting, very interesting. You can control wheelchair, you can control switches with the help of brain signal. So this particular paradigm, this is generally called as paradigm. This particular structure you can create by your own. Believe me, you can create by your own. You can just create a matrix, and matrix may have certain numbers, and you can ask the person, watch the number one for 10 seconds, and then you can when while he is watching that number one for 10 seconds, get the brain signal, convert into command, and that command can be connected with particular operation. So whenever the person wants to do that operation, he will watch number one for 10 seconds. So this is very, exciting application. It provides assistive, adaptive, and rehabilitative application. There is some disorder, there is some disability that can also be corrected with the help of feedback signal. It's absolutely possible to control machines without movement of body. This is what I was trying to explain. You do not need to move your body. You just think and you watch certain thing. So this particular screen or a paradigm or the display kind of device can be put in front of the person who wants to use this. This particular screen can be in his laptop, or better to have in the laptop. So the display will be there in the monitor of laptop, and with the help of watching this particular display, he can control his wheelchair, or he can control anything which is there inside his home. Useful in neuroergonomics. Ergonomics is related to this particular wheelchair. He can improve, he can increase or decrease the comfort level, he can change the different ergonomics of the wheelchair. And smart environment, neuromarketing, education, robotic based games, entertainment, these are different applications of this kind of brain computer interface. We also call it as BMI. In the last lecture I was telling you, brain computer interface is also brain machine interface that is used to collaborate between IoTs and BMI technologies. Internet of Things, you understand very well. It results in a smart environment such as smart home, smart transportation, workplace, and so on. Right. So I do not need to probably, define IoT. Can anybody define Internet of Thing in a single statement? Can anybody? Can anybody try defining what is Internet of Thing? Just one line definition of Internet of Thing. Yeah, anybody? Internet of Thing IoT is a brilliant example, rather a combination of sensor technology and artificial intelligence. You talk about any IoT, it has two major things. One, sensors, that is sensor technology, and second is AI and ML model. So sensors are used to capture the data, and how data is interpreted and suitable commands are generated by using AI and ML models. So IoTs are the combination of sensors, that is sensor technology, and AI ML model. So sustainable healthcare. Yesterday we started introducing with cognitive science, brain computer interface, and sustainable healthcare. So, brain computer interface is popularly used in healthcare. But what is sustainable? It is related to, that improves quality of life. As per World Health Organization, if you look at the definition of sustainability, it defines environmentally sustainable healthcare as a health system that improves, maintains, restores health while minimizing the negative impact. This is the definition of sustainable. The healthcare that improve the quality of life, quality of an individual. It maintains the health. Remember, it maintains certain level of health. For example, quality of sleep. If you can maintain a particular level of quality of sleep, that will be a sustainable. Sometimes you get very high quality of sleep, sometimes you get very bad quality of sleep, then it is not sustainable. Sustainable means how do you maintain it? If you're enjoying good health, how do you maintain it? Does brain computer interface play any role? The answer is yes. We'll understand little later. So on the environment and leveraging opportunities to restore and improve it to the benefit of health and well-being of current and future generation. So it may be related to social. It's definitely solving the problem of society. It is affected by the environment. And when you produce something on sustainability, when you provide some sustainable solution, of course, it also impacts the economy of a country or a economy of nation. So there are three factors which are very important in sustainability: society, environment, and economy. If these three are included in the healthcare, it becomes sustainable healthcare. So when you talk about biomedical technology can be used for game interaction, robotics control, emotion related studies, positive emotion, negative emotion. Somebody is disheartened, somebody is excited, somebody is motivated, somebody is upset. Do we or can we study using BCI? The answer is yes. Are you tired? What is the level of fatigueness? Fatigueness is high, fatigueness is low. When you are solving complex problem, is it increasing the fatigue level? When you are at rest, is it decreasing the fatigue level? All these can be studied and quantified by using a brain computer interface. I have already explained and used this term sleep quality again and again. Sleep quality can be studied, clinical trials can be made, and so on. So specific to brain computer interface related to biomedical technology, I think if you remember, this particular diagram is coming again. You acquire the signal, you extract the features, you translate the features into commands, and those commands can be applied for what kind of applications? Either to enhance the ability, either to restore certain ability. Suppose you are not able to move your hand or palm properly, that particular ability could be restored. Believe me, that could be restored by using either some practice or some rehabilitation technique. You can replace, by assistive technology. You can supplement something, you can improve the performance of a particular organ using the brain computer interface. So this is specific to biomedical technology. When we advance to the next lectures, third or fourth or fifth lecture, fourth or fifth day, we'll understand these applications in particular. I was using a terminology called as P300 BCI, where one of my PhD scholar did his thesis into a P300 BCI for those who are having certain disabilities. So that case study also I've been including the next lecture. Okay. And then there are wearable devices. You can have n number of wearable devices, smart IoTs. You can use those wearable devices, those IoTs over your skull. You can use a forehead. I was trying to tell you headband headband kind of EEG device also comes in the market. Ear EEG, you can use some EEG that can be connected with only your ear. So there are different versions which can be used for disease management. How can you use for disease management? Suppose you are wearing a headband, and that IoT is helping you, to assist your stress level, to assist your learning level. So you can manage your disease, you can manage your learning ability, rehabilitation therapy. You can appropriate provide therapy to the person. You can do health monitoring. You can provide communication assistance to the person who is having certain disability, and you can also control different equipments. So all these things can be done by using wearable EEG device based brain computer interface. And in all those devices, the cycle is again same. Let us not repeat again and again. You capture the brain signal, digitize the data. Digitizing the data is important because digital computer understand the digital data, and then you can understand that data with the help of feature extraction, training, mathematical modeling, artificial intelligence, classification, generate the commands, and you can apply any applications. You can generate the feedback, or the stimulus can be also generated to give the feedback to the person to do some corrective or remedial actions as a feedback. So, what is the takeaway from this particular PowerPoint presentation? What did we do? What did we do? Let us not repeat. We have understood as a cognitive science as a multidisciplinary domain. And what is cognitive science? I hope by this time this is very clear to everybody that cognitive science is nothing but study of mind, rather study of human brain, which is used in a number of applications. And BCI has multifaceted applications either in healthcare, smart environment, smart transport, smart healthcare, sustainable healthcare, and so on. And sustainable healthcare greatly benefit from the BCI applications.